Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over this Desmos activity, function transformations. I chose sixth period because there was most students were there and doing it, and so I figured this would be a good class to look at to see if there are any common misconceptions or questions. So for number one, the question was which one doesn't belong, and most students chose this one here because it goes upside down. If you look at some of the justification here, um, yeah, everybody was looking at it to be the one that stood out because it went upside down. Okay, number two was pretty much just dragging it up too. But then when you can't drag it, when you have to change the equation, it gives you this suggestion here, and the plus two would move it up two, and so that's what would get you to cover up the red uh, function. All right, number four. This one now moves horizontally, so left or right. If you're trying to move it left or right, you do want to add or subtract a number where the x is. Um, Now, if you did this first, you would notice that it moved it up, which was the last slide. But yeah, this one would move it in a horizontal direction. Now, this student here pretty much left it just like that. But if you count the squares from the starting point, you would have to actually move it five, and so this would be five here. So if I change that, it'll cover up the red graph. Okay, number five. The question was which one of these is not like the other. Basically, when you talk about transformations like this, where you move it up and down, right and left, that's called rigid transformations. And rigid transformations basically have to match up perfectly. The shapes have to be congruent. In math terms, that's what you would say. But in this case, you could see that this handle was a lot longer on C, and so you see that justification there. So yeah, it's not an exact copy, right? All these other ones are pretty much exact copies of the original. So if you look at slide six, I see a lot of students with this green here. That's basically confirming what you said before, and showing that it's you can't cover up all of this green here on part C. So I'm gonna go ahead and look at this one here and just give some feedback on um, you know where this could be in the right direction. So B is in the right direction because from here you would have to go up three in order for it to match with this orange one, but you'd have to also move it to the right two. So in order to move it right or left, you'd have to put it in the parentheses. So if I put, let's say I put plus two, that would actually move it to the left. If I put minus two, that would move it to the right, and then B is covered up now. Let's see, D is also pretty close. I think it's a little bit too far to the right, but let's move it down one, two, three. So I think this is D. And if we move it down three, that should get it to match more. Now, whenever you're trying to move it down, it's got to go after the parentheses. So I'm going to put minus three. And yeah, I shifted it down. Now, this is a little bit too far to the right. If I move it two to the left, I'm going to take away two from five. And then maybe make this a three. And yeah, that matches. Now, for A, I believe it's this one here. So this is on the right track. You just got to move it down five. So I'm going to have to put this number outside the parentheses. That's it. So the main thing to know here is if it's in the parentheses, it's going to shift it right or left. And if it's outside the parentheses, it's going to move it up and down. So that's the main thing. And then also C is impossible to match because it's not the same length on the top. Okay, now number seven, slide seven gets into dilations, which is stretching. And so that's going to come from putting a number in front of the function here. like this 2 here. Now, you may have remembered doing this with the other activity where you're drawing functions, and if this was a negative, it would flip it upside down. So that's another effect that that could have. But yeah, 2 is going to get you this dilation where it matches. So if I look at this one, I noticed that this one was an uppercase letter. I don't know why, but it only accepts the lowercase level um, for a function. So if I click that, then you would have been able to see that the 4 is a little bit too large. So then you might have made it a 3 and then ended up getting a 2, which was the correct answer. So yeah, I'm not sure why the Desmos itself doesn't recognize the capital F, but yeah, I'm sure many students were maybe not seeing the graph for one reason or another. Okay, now this one I noticed E being one of these graphs that's kind of impossible to get to. So a lot of students that did all the other ones were struggling to get E, and I tried it too, and it was very difficult to get it to match. But it actually wasn't a perfect match. So slide 10 talks about why D was not um, able to be matched, and it just was too wide, or it really couldn't match up perfectly. Let me show you this example here. This was pretty close. So all these functions were able to be matched. Actually, C was another one that was not a perfect match. So let me show you why C wasn't. So if I make this, let's say -0, let me move it all the way. Let me move it really far out of there. Okay, notice that this C has this top part of 1, 2, right? But this here has a length of 1, 2, 3. So if I move this back over here, it would look like it matched it perfectly on the top, but this actual graph is a little bit too long for C. But if you look at this length here, like this handlebar here, it actually is the same length, but it's just the top part. So again, if I shift it the other way, again, let me go with 1. It looks like it's a perfect match, but this is actually the excess. So C is actually not a perfect match either. Okay, so it's actually C and E that do not match. Yeah, E is the angle and C was the length of the top. So here, the rest of this is kind of you creating your own. I just wanted to actually mention just one more thing before I ended this, and it was this here. When you flip it, um, some of you had these ones where you flipped it left and right versus up and down. So if you ever have to flip it left and right, you're going to end up putting the negative in front of the x. So if you flipped it upside down, that would be a negative in front of the function. But if you wanted to flip it not upside down, but to the left or to the right, that would be a negative in front of the x. And so that was like one of those other transformations that was a little bit tricky, but yeah. So yeah, that's pretty much it. Um, the rest of this was just kind of messing around with it and everything like that. But yeah, I saw a lot of your efforts in doing this assignment, so that makes me happy. And so yeah, I'm still doing well, and I'm just pretty much just waiting it out and seeing how things go. So keep up the good work, and I'll be keeping track of how you guys are doing, and if you have any questions, just let me know. All right, have a great day.